This is the animation page, and in this animation page we can see some of the things. We can see some colored regions, we can see a line, we can see some source, some object here. And before experimenting this, let us try to know what these are the objects. Initially, we should understand what this white region and what this blue region represents. See, these two regions represents two mediums. Then what are the mediums? Can we give any examples for medium? Yes. As an example, we can take air, water, glass, oil. These are the examples for medium. So to experiment this phenomena, we need two mediums. What is a phenomena here? It is a refraction, and this experiment is done by Snell. So whatever the result he got from his experiment is stated as his laws. So that is why this law is also called Snell's law of refraction. Yes. So as an example, let us say the white region is a air medium, the blue region is a water medium. So to undergo this refraction, we need two mediums, and the light has to pass from one medium into the another medium. So to undergo this refraction, the light has to pass from one medium into the another medium. And you are watching on the screen, there is a light source. It is actually a torch. If I push the switch, a ray of light will come out of that source, and it will fall on interface of the two medium. What is interface? It is a layer which separates these two mediums. It is called as a interface of the two medium. So here we can adjust the position of this light source. See, I can vary the position of this light source as our requirement. So if you press the switch, light will come out of it. See, I can vary the its direction, and still the light is incidenting only at this point. See here, this is E. At this point, the light is incidenting. So this is called as a point of incidence. At this point, light is incidenting to this. Okay, so we have to draw a normal to this point of incidence, because by drawing the normal we can measure some of the angles. So the use of drawing normal is to measure the angles. So we have to draw this normal always to the point of incidence. See, this is the point of incidence at which we should draw a normal. Let's draw. See here, dotted line which indicates the normal which I drawn to the point of incidence. This is the point of incidence. Now let us incident a ray of light. See, we are incidenting the ray of light. As we incident the ray of light to the point of incidence, we can see two rays. One ray which is a dull in color, another one is in a bright in color. So what is the indication? See here. So when the ray of light is incidenting on the interface of the two media, what will happen is, if the mediums are transparent, See, I consider a water medium which is a very transparent. So when it is incident on such a transparent medium, a part of light will be get back or come back into the same medium. See, this is a air medium. So to the same medium, a ray of light is coming back after striking the interface of the two medium. So this ray will strikes on it, and a part of it will come back to the same medium, and the remaining part will passes on into the another medium. So this is a passed light. This is a ray which came back to the same medium. So this ray, the ray which came back to the same medium, can be called as a reflected light. It can be called as a reflected light, a light which get back after striking a surface. A light which come back after striking a surface is called reflection. So this is a reflected ray. And a light which passes into the another medium, and it has to move from one medium to another. So the direction of ray changed. See, actually the direction should be this way. See, this is the actual direction. If the both are the air medium, then the light will pass like this. But if I introduced water medium, the direction of light changes. So this phenomena is called as a refraction. So the direction of this light changes as it moves from one medium to the another. This process is called as a refraction, and this is done by scientist Snell. And this ray is called as a refracted ray. The ray which is in the another medium when a ray travels from one medium to another. Okay, so this is the incident ray, this is the reflected ray, this is the refracted ray. Okay, now let's see by what happens by changing the position of this source. See here, see, you cannot see reflected and refracted light along this direction, and if I vary like this, these directions of these lines, reflected and refracted lines or refracted rays, also changes. So by what angle it changes? And we can also think here that at what angle we are incidenting this incident ray. At what angle this refracted ray is refracting. And also we can calculate by what angle this ray is reflecting. So to calculate or measure these angles, we have drawn this normal. So let us try to find the angle by placing protractor. See, this is a protractor. I am placing like this. Zero of this protractor should coincide the normal. Now I placed here. Now you can see the angles here. See, let me vary like this. Very beautiful. See, what is the angle? See here, this is the 31, right? 30. So this is the incident ray. So angle of incidence, right? A ray is incidenting at an angle of 30 degree. That angle is called as a angle of incidence. How did we measure? How did we measure? See, this is the normal from which we are measuring the angle. Okay, so the angle between this normal and this incident ray direction is called as angle of incidence. So angle of incidence here is, this angle is 30 degree. And look at this, is the reflected ray. Look at the reflected ray. That reflected ray is also making an angle of how much? 30. So this is the angle. See, from normal we have to measure the angle. So angle of reflection is also 30 degree. But look at here. This is the refracted ray. So the refracted ray making an angle of 20 degrees. See, 0, 5, 10, 15, 20. So this refracted ray making an angle of 20 degree, and so the angle of refraction, this is angle, see, this is angle, that is equal to 20 degree, which is less than this angle of incidence. Angle of incidence is 30 degree, angle of refraction is 20 degree. So we can define the angle of incidence, angle of refraction. Angle of incidence means it is the angle between this normal and the incident ray direction. Angle of refraction means it is the angle between this normal and this refracted ray. Yes. Now here we observed a phenomena that angle of incidence is equal to the angle of refraction. Here we incident this ray at an angle of 30 degree. For the same angle, the ray is reflecting. That is why angle of incidence is equal to angle of reflection here. Whether this is true for all angles, let us see. That means, since we got angle of incidence is equal to angle of reflection for 30 degree, then whether it is possible for all other degrees, let's see by varying the position. See, now I am keeping it angle of incidence 60 degree. If I place it at 60 degree, angle of reflection we got 60. That is why angle of incidence is equal to the angle of reflection. Okay. So this is what we understood from this. Also see here. So here angle of refraction is 30 and nearest to 40. But angle of incidence is 60. So that is why what we can say is the angle of refraction is less than the angle of incidence. So this is what we can understand from this. And also you can see, since angle of incidence is greater than this angle of refraction, we can say this ray is towards this normal. See, as you increase angle, the angle of refraction doesn't vary much. So that is why what we can say, when the angle of incidence is greater than angle of refraction, then this refracted ray bends towards the normal. It will bends towards the normal. In this case, you can see the mediums also. Ray is traveling from this medium, rarer, to this medium, air medium, into the water medium. So in that case, ray is bending towards this medium. So this air medium can be considered as a rarer medium, and this water medium can be considered as a denser medium. So it doesn't mean that it is a mass density, which means this rarer and denser mediums are not equal to mass density of the medium. So see, this rarer and denser medium are determined by the ratio of the velocities of the medium. Okay. So here, since ray is traveling from rarer to denser, in that case angle of incidence is greater than the angle of refraction. So the ray is bending towards the normal. Then what will happen if the ray is traveling from this denser medium into the rarer medium? Let's see. Let's see. See here. We are incidenting from this denser medium into the rarer. Now we are incidenting the light from water to air. That means we are incidenting the light from denser medium into the rarer medium. You can observe here, now the angle of incidence is 30, but angle of refraction is 40. Now the angle of refraction is greater than the angle of incidence. So in this case, ray is traveling from denser to rarer, and here you can see as you increase angle, there is a more angle will covered by this refracted ray. So the refracted ray will bends away from the normal, which bends more away from the normal. So this happens when a ray travels from denser to rarer medium. So let us again see some of the phenomena here, some of the things. We can also see intensity. See this, let see the intensity. 100% intensity, which is incident light. Refracted light have only 94 intensity. What about the remaining? It is here. It is 5.37 intensities reflecting there, and almost 94, almost 95% of intensity is refracting here. So this is about in terms of intensity. See, as you vary, see here, when the source of light is incident at 90 degree, then it is passing along the surface of the two medium. See, it is grazing the surface of the two medium. Okay, and if you incident at an angle of 0, angle of incidence is 0, then you cannot see a refracted and a reflected light. So this is regarding this refraction of light.